Hi everyone. Very excited to be here for the first time in Germany and in the Perl workshop. And my name is Mickey. I work for Booking.com. And in case you haven't heard about it before, we are still growing and we're hiring. So if anyone is looking for their next challenge, they can definitely catch me later and talk about it. I wanted to talk about something really cool that we did at work. Basically, we were tasked with this very simple case of let's break communication channel between clients, which are web services and a database, specific database, because for some specific data, we didn't want those clients to have direct connection to the database, and we wanted to put in a web service between the two to have more flexibility and visibility on what's going on through another host. So far, sounds boring, right? It's just REST API. Everyone is very familiar with it. We all do REST APIs. We love them. We use them all the time, all of us. Some of us create, maintain multiple ones at a time. It's very simple. They are a very simple way for us to represent data as a state of the data as it is on the server in a way that the client can read it. The data can be anything. We don't care how it is on the server side. It can be a table on the database. It can be static file. It can be a document in Elasticsearch, whatever. We don't care. We just see some representation of it, which we can read or use to update if we want to do manipulation of the data. So usually, you have a very simple way to access a resource on the server in a REST API. You just say, hey, I want to read, so I'm sending a method get, and I'm uniquely identifying the resource on the server. In this case, I want comment number 12, so I'm saying type is a comment, which in this case just represents the table name, and then a unique identifier, the primary key, number 12. The server will respond with something that is usually a serialized JSON that will give me the result. This is what you asked for. This is what I have in the database for this comment. Now, it may return something like this, and it may even return something like that. How do I know how to read that? What is the format of this JSON structure? This is where we find a problem, because we don't have a definition of how the JSON is structured. Every time we build a REST API, and I find myself as a web server-side developer having this conversation over and over with the client-side developer, what I send to you and how do you read it, what you send to me, how do I read it, if I need my server to be able to communicate with multiple clients, then I have to have specific versions for each one of them. If the client wants to connect to multiple servers, it needs to know how to format its data in order to have each of the servers know what it wants. This is kind of a time-wasting procedure. And we find ourselves doing the same thing over and over. I mean, you can build your own local thing, but then it would not be able to communicate with like a third-party server. So we wanted to focus on what we are passing between the server and the client, not how we're doing it. For us, this is bike shading. This is waste of time. And to solve this problem, we figured that we need a protocol. We need a way for the client and the server to know how to communicate without us implementing a special library or a special piece of code for it. A short research, we found JSON API. JSON API is fairly new. It has the first stable release from late last year, but it does exactly what we're looking for. It defines exactly how the server and the client should communicate, what the format of the JSON should look like, what the headers that are being passed around, the statuses the server returns, everything that needs to be like forgotten as far as implementing this part of the communication. The missing link in the stack. The list of implementations, one of the bonuses that JSON API is new, but it already has a lot of implementations in many good languages and PHP. And thank you. We didn't have an implementation in Perl, so forget the line there that says Perl. But we thought that the spec looks really cool. We want to use that. And let me give you some example of how JSON API works. A very similar request, just like we did before. This time I want an article with a number 3. The only thing I need to change in order to fetch it is just to tell the server through a header that this is a JSON API request. The server will know what to do with it. It will return a JSON. You don't have to read this. I'm just going to go through some of the sections in the JSON just to explain what is the format here. This is an optional one. It's just the version. The spec has multiple versions. There is a stable one, 1.0. There is one that is coming, 1.1, and there will be future ones. Guaranteed to be backward compatible, but at least if we want to know how to read the specific one, we better know the version. It also comes in the headers, but it's always nice to have it in the data. There is the data section. So I'm going to break this down for you. The data section has the unique identifier. So you will have the type and the ID. In this specific case, this comes from a table. So the type is the name of the table. The ID is just the primary key. We have some attributes, which in this case, just the rest of the columns in the table. We have a link. If we asked for multiple resources, then we would have an array. Each will have its own link. The links can be relative. They can be full. It doesn't matter. It's a choice you can make when you build a server. And we have relationships, which is a really cool feature, because this is basically the link of this resource to other resources on other tables. You can see it as a foreign key, or it can be just through a linking table. But you get the information about how this resource is related to other resources. And I will show you in the next example how you can also pull the information through that. So here is a very similar request. I'm just making use of some of the URL parameters that the JSON API spec allows us to use. One is the include, the other one is fields, and it works like this. This time we get a different JSON. We ask for specific fields. So for the articles, which is the type of this document, we only want to see, instead of a select star, we want to see just selects of specific fields. So we get them in the attributes, only title and body. The author is there because the relationships are also top-level members. So a relationship is basically like an attribute, and we want to see the relationship section on the top there. It needs to be specified in fields, but also I stated include authors. Basically, I told the server to also send me the full resource of the author that is related to this resource. So I can apply other filters on the included type as well. So if I said fields people, I could also play with the attributes or whatever I want to do with the included one. And there are other parameters that you can use according to the spec, like sorting, paging, filtering, a lot of different things. I can go on and on about JSON API. It's worth its own lecture. It's a big spec, and I recommend you read it. I want to talk about PONAPI. So, as I said, we didn't have a Perl implementation. First, I need to explain what the name is, because I was asked that before, so I came prepared. We wanted to name our project JSON API, but the name was taken. So we removed the dash, the name was still taken. Then we figured, hey, in JSON, JS stands for JavaScript. This is not JavaScript. So we replaced it with P for Perl. And of course, Perl object notation means a lot. But we like the name, so we kept it. And this is how it's called, PONAPI. This is how we pronounce it. This is an open source project that we did at Booking, which the company was very nice to us. They allowed us to do this as an open source, not at the end of the project. It was not released and then became an open source project. We started this as an open source project from day one on my personal GitHub directory. And it was available. You could see and follow basically what I do at work. I hope nobody did. But it was there. It was public. We had a couple of people contributing to this project because we had some onboarders in the team. They came, they contributed a little bit and moved on to other projects. But mainly, it was developed by 3 people. Myself, Brian Fraser, he's a core Perl developer, Hagmeyer, if you know him, and Stephen Little, which I guess some of you know. The project is out there on GitHub. You can check it out. You can fork it. You can look into the issues. You can open issues, of course, and we will be glad to get some pull requests. It's also available distributed on cpan as 2 separate distributions. There is a server one, and there is a client one. And I'm going to talk about them in a minute. In the list of implementations on the JSON API page, you can find it under Perl. It's the only implementation, both under servers and under clients. We understand that with time, maybe there will be a need and some other people will add more implementations, but remember that PONAPI will always be the first and the best. Server is very easy to install. You just install it from cpan, and it's a plaque-based service. Thank you, I don't need all the time. It's a plaque-based service, very simple to run. You basically run it. You can just mount it, and it will serve the data that you have. There is one step missing in order to make this actually work. I'm going to talk about it in the next few slides. We also provide you with a command line utility. It's called PONAPI lowercase. It will be installed into your local binaries tree. And you can run it with 3 commands. The last one is manual. It's just do the Perl doc on the manual. It's a very long and detailed manual that Brian Fraser compiled, and he did a great job. It will take you by the hand and lead you through the process of hooking this to your data, and you will be able to run everything after going through the manual. The first one that you might want to play with is this demo server. As soon as you install it, just run demo-s. It will build a small database, SQLite database with some data in it, and we'll just start serving it from, by default, 5,000 port, but you can also specify a port if you want another one. And you can also run queries. Running it with demo-q will randomly generate a query for you, and we'll run it. The query will be for one of the tables with some parameters, and every time you run it, you will get a new one. It's really nice. You can run it in a loop. I did it with any event, and it was really nice. I was just bombing the server, the demo server, and getting all those results. It's really nice to see. This looks like this. You will get the URL of the request that was sent, the real-time response that you got, and the content type. You can omit this part if you want. You can also run it with -JSON if you're passing it into like a JSON pretty print or some other JSON reading utility. You can just have the JSON only. The most important part of this utility is the gen. Gen is basically building your working environment. The mandatory flag is there. You basically tell it to create a directory for you. This directory will contain several files and libraries. Repo. This is the only hard part for working with PONAPI. You need to hook your database to it. You need a module that we can use by creating an object of, just calling new with some parameters that you put in the config, whatever you want. And this module needs to be able the object needs to serve those methods in order for us to be able to communicate with it. Not all of them are mandatory. If you don't want, for example, relationships, they can all be like empty sabs, that's fine. And of course, all the data manipulating ones also can be empty if you don't want read-write access. So it can be a very simple thing to build. But and most of you, if you have a database, you probably have an ORM, so you can just hook it. It's just one small layer on top of it. It's not something new that you need to reinvent. You can also say, instead of repo, you can say new repo, and it will create a skeleton of the file and the library in the directory for you. In this case, it will just check whether this module exists and is loadable. It will shout if not. The conf can be passed, but can also be omitted, and then a default one will be created for you, which is mostly useful. You can use it or tweak it a little bit. There are some things in there like, does this server support sorting? Yes or no? You need to specify it because the spec says that if you don't support it, then you have to return a specific status. If not, then let it work. And we want to make that distinction, so we have to configure the server to work with the spec. And everything will always return a valid JSON API response. Whatever you do, when the server is up, no matter what the request is, it will always return a valid response, even if it contains error inside. And that's a very important thing, because it means that your client will never have to deal with different types of responses. Unless, of course, the request never reached the server or things like that, in which case we cannot do anything about. But as long as it comes from the server, it will always be a valid JSON API document that is coming back. This is how it will look like, the directory after I generate it. This one is with a new repo, so it will just create the library. It also adds the PSGI file, so something that you can use to run it. We always add the HTTP method override the middleware as well, just because it works with patches for updates. So some of the clients don't support patch, so you can use post and override it with patch. So we have the middleware there, but you can remove it if you don't like it. The client, very simple, very simple. Just create an object, pass the request through in a Perlish way, and you get back a JSON, which is deserialized into a hash. It will always be a hash, because that's how the JSON that the server is sending, the top-level document, is a hash ref. Inside it can have data as an array ref, but the top level will always be a hash ref. And you will get everything in a structure that you can work with in your code. There are some more features that are coming, especially around extensions. The spec supports extensions. Some of them are official and some of them are custom. The main one that we are mostly interested in is the bulk extensions, is the bulk updates extension, because we need it. We already have it implemented. The only reason why it's not out there is because the spec is not finalized around the negotiation of extensions yet. They promise to have it soon be ready, and it will be in the next version. As soon as it is, we will release it. Some more pointers for reading about it. The spec itself, it's in the JSONAPI.org website. They have a very nice forum there as well for discussion about issues and clarifications. There is the directory, my GitHub directory, where the code is, and of course the distributions on cPen. We are planning to also add some more distributions. We want to split some things, but that's some utilities to help you work with, even if you don't want this Slack-based service, but you want to build documents for your existing thing, you may be able to use it as well. And with that, I'm done, and thank you very much for listening.
And thank you very much for talking. And now we still have time for maybe 2 more questions.
It's more of an annotation. When I first saw the title of your talk, I thought about Tokipona, the artificial language. Do you know it?
Actually, I do because Maxim Woods, the guy who gives the talks about Okipona, he works at Booking. He's actually working on my previous project at Booking. And yeah, the resemblance in the name is something that I was aware of. Absolutely. Yeah, it has nothing to do with it. Of course, you can serve Tokipona as a...
So, second question.
Is this JSON API thing, is basically hate OAS, right?
Is?
So it's
Sorry.
basically a hate OAS format, right? So you have this whole hypermedia thing that that it says where to go and what to go. So there are a couple of other similar formats like this HAL and I forgot the name of the other one. Why this one and not the other ones that are already there?
The choice was basically, well, we were free to choose whatever we felt. We saw that it's trending up and there are a lot of implementations out there already and fairly quickly. It just looked like the right thing to do. I think the idea came from a tweet that Stephen read about it while commuting to work, and he just figured that this one is a nice one. It's also developed by some core Rust language developers. Steve Klubnik, if anyone knows, is the main author of this spec. So it comes from a good place, and we trust this technology.
Okay, final question from Max.
Yeah, I was kind of expecting something like JSON schema or something so that both server and client know they are talking about the same data structure. Does PONAPI or JSON?
So JSON API, the spec has a schema. We use it for testing, so we know that we adhere to the schema, but I mean, it's available. You can go on the website. I think it's linked through some of the either the examples page or the FAQ. There is a link there. There is a schema. Yes.
Okay, thanks again.
Thank you all again.